Hello everyone. In last lecture I have already started about common heat treatment processes. There I have already discussed about preheating as well as interface temperature in details. In today's lecture I will discuss about another common heat treatment process, that is post weld heat treatment. Here PWHT represent, P represent post, W represent weld, H represent heat and T represent treatment. So, in this lecture I will discuss in details about post weld heat treatment. Apart from this post weld heat treatment, I also will discuss some other very common heat treatment processes in details in today's lecture. So, this is the content of today's lecture. Like first of all I will discuss about different types of post weld heat treatment, especially I will discuss about the type of post weld heat treatment like post heating, stress relief, these two different processes in details. Apart from this thing, some other heat treatment process details also I will discuss, because this is also required for welded specimen, or you can say in case of welding these types of heat treatment also have a lot of application. That is why we need to know about some other heat treatment processes like annealing, normalizing, tempering, then aging, or you can say precipitation hardening process. So, these in details in today's lecture I will discuss. In case of a welding process, the overall thermal history you can say can be represented like following diagram. Here you can see this is horizontal axis represent time and this vertical axis represent temperature. So, what happens here you can see initially I have shown you three different horizontal line you can see. After that generally in middle there is a exponential types of curve. Apart from this thing at the end there is also another temperature profile you can see. So, from here what you can observe that this first initially this first black line represent the you can say it is started from room temperature or ambient temperature, and after that it generally heating due to welding heat source. After that once the high welding heat source move away from that point, then how the temperature is cooled down, that thing generally represented by this black line. So, this first portion of this heating you can say is called preheating portion, or you can say preheating zone, and this middle zone generally called you can say welding transient thermal zone or welding transient thermal history zone, and this last part of this curve you can say is known as you can say post weld heat treatment zone. So, in this first figure, that is the black line generally is you can say is represented as like here we have started from ambient temperature and it is heating due to welding torch. After that it is when the welding torch move away from that zone, then how the temperature is there, that thing generally we observe. So, how it is little bit here I am just representing in right side. Let us this is a weld specimen. Here at this middle zone we are doing the welding. Now, let us consider we are considering a particular point phi. At this point phi generally how the temperature over the entire welding operation, that means preheating, welding as well as after welding if there will be any heat treatment operation, due to that how the temperature distribution is look like, that thing just here it is showing. This is the first figure. Here you see here generally you see generally welding is started from here. So, after that generally to reach here generally it takes some time, that is why what happens here initial temperature for reaching here the temperature is room ambient temperature you can see. After that generally once this heating torch or you can say weld torch moves to this location, then this due to conduction phenomena what happens in this location your temperature will rise very rapidly, you can see. After that, once this heating torch move away from this zone, then what happens, this point P start cooling, it start cooling, and how it is cooling, that things also it is showing. Okay. So, after that after some time generally it is returned back to, you can say, ambient temperature. Now, from there what are the three different curve here I am showing. This first curve represent here, generally you can say here no preheating is done. No, here you can see, because here preheating temperature is ambient temperature, here no extra heat is applied there. This second curve, that is means blue curve, it represent generally it initial temperature, generally we provided some initial temperature, that means some initial preheating temperature we provided. This is generally called you can say medium preheating curve, this you can say. And this last this third curve, which is generally you can say 1, 2, 3 I am representing this third curve, here generally initial temperature is quite high, this is generally you can consider as high preheating curve or high preheating types of process. Now, why I am showing this thing, because during a welding process what are the different thermal cycle points subjected to, or the entire plate subjected to, that I am just showing. Okay. After that, generally once you can see on the preheating is no preheating is there, at that time you see here you can see comparatively very rapid cooling is taken place. That means time taken from this, you can say time taken from this peak temperature to room temperature, you can say time taken from this peak temperature to room temperature is this much. Okay. Now, after that once we use this medium preheating, then you can see this time generally taken from this peak temperature to room temperature, it is initially let us T1, then T2. After that once we further increase the what it is called preheating temperature, then also you can observe that cooling time required from this peak temperature to room temperature, it is T3. So, what you can observe from this figure, here you can observe that T3 is greater than T2 is greater than T1. That means, once the preheating is increased, then time required to cool down from peak temperature to room temperature is increased. What I am telling, you understand? What does it means? It means you can say your cooling rate decrease. So, once cooling rate decrease, then generally it helps to escape the what it is called hydrogen from the weld, as well as what it is called heat affected zone. As well as it also help once cooling rate decrease, then what happens, chances of formation of martensitic types of structure is also reduced. That is why what happens, these types of preheating generally is required to do in case of welding operation, because due to these things you can say dt by dt, this time required for these things, that means temperature is decreased. That if this time required for cooling rate is decreased, then what happens, chances of formation of martensite is less, that you can say. As well as what happens, here chances of escaping of the hydrogen from the weld as well as heat affected zone also, it gets more time. So, it can more the hydrogen can be escaped from the weld zone. So, it reduces the chances of HIC, that means hydrogen induced cracking, this you should keep it in mind. Now, after these types of preheating, these advantages we are getting, then what happens, sometimes what happens in your weld zone, there is a chance of remaining some what it is called martensite, or remaining some what happens non-transfer austenite also can be there. That is why after cooling also generally this weld specimen is required to some what it is called, after completion of welding also it is required to some other types of heat treatment after welding. that heat treatment is known as generally post weld heat treatment. So, this post weld heat treatment generally is a very popular heat treatment process by which whatever the different types of martensitic structure, or you can say hydrogen is induced and it is entrapped inside the weld zone, that can be removed from that weld as well as heat affected zone, as well as this martensitic structure converted to or other form of structure like bainite or perlite by using this post weld heat treatment, which generally reduce the chances of cold cracking, as well as it also helps to reduce weld induced residual stresses. How it is, everything in details I will discuss in subsequent slide. Now, this post weld heat treatment details I will discuss in today's lecture. So, first of all, what is post weld heat treatment and why this post weld heat treatment is required, that I will discuss. After that, I will discuss about what are the different types of post weld heat treatment, and these different types in details also I will discuss in this today's lectures. Generally, post weld heat treatment means you can define any heat treatment generally which is performed after the completion of welding, is often used to improve the properties of the weldment, is known as, you can say, post weld heat treatment. That means, after completion of welding, whatever the heat treatment process generally we use to improve the property of the weldment is known as heat treatment process. There are generally two types of post weld heat treatment we commonly used. What are those two types of heat treatment process? One is called post heating post weld heat treatment process, another one is called stress relief heat treatment process. Why this post weld heat treatment process or stress relief post heat treatment process are required? Everything in details I will discuss. Generally, this post heating we used to do to reduce the chances of cold cracking, okay, or to mitigate the chances of cold cracking, whereas in stress relief post weld heat treatment process also mainly used to minimize, you can say, minimize the weld induced residual stresses, weld induced residual stresses. So, the generally in case of welding process due to fast cooling, you can say, if there will be fast cooling, there is a chance of formation of martensite. Now, we know martensite is a hard structure compared to other phase of especially in case of steel material, other phases like perlite or bainite types of a structure. Compared to those structure, martensite is more harder. So, during this post weld heat treatment process, what we used to do, this martensitic structure generally we tempered by raising the temperature of this weld specimen. After that, generally due to this raising temperature and tempered of this martensitic structure, it transformed to ferrite and carbide. Once this martensitic structure convert to ferrite and carbide structure, then its generally hardness reduces, its hardness reduces, but its ductility and toughness increases. This you should keep it in mind. Apart from these things, due to this tempering, or you can say post weld heat treatment process, it also reduce the weld induced residual stress. This you should keep it in mind. So, you can say generally post weld heat treatment process is mainly used, you can say, to reduce the hardness, increase the ductility, as well as increase the toughness of the welded specimens. What it does once you will do these things, because once you will do this thing, due to this effect, generally chances of HIC, hydrogen induced cracking, is reduced drastically. Apart from these things, it also reduces the residual stress which is induced in the weld structure, that is also reduced drastically. This post weld heat treatment process, that is post heating and stress relief operation, it is generally used to do below lower critical temperature, that is A1 temperature, you should keep it in mind. In case of mild steel, it is generally 723 degree centigrade temperature, you know these things. So, it is generally carried out below this temperature limit, you can say. In case of mild steel it is this, but some other steel it can have little bit higher range, what I am telling, understand. But another things you should keep it in mind, this post weld heat treatment process is a cost effective as well as time consuming phenomena. That is why what happens in some cases where there is a less chance of this types of hydrogen induced cracking, those cases generally post weld heat treatment process is not preferable, because if you will do these things, then what happens, it will generally increase the cost. So, and what happens, and it is generally you can say unjustifiable cost may result if it is done. Okay. Now, we will discuss first of these two categories of post weld heat treatment. Generally, this post weld heat treatment we used in case of ferritic types of steel. What is ferritic types of steel? Little bit I am explaining about ferritic types of steel. Here generally ferritic type of steel, the carbon percentage varying from 0.08 to you can say 0.2%. Here generally silicon composite percentage is around 1%, manganese percentage is around 1 to 1.5%, and for stainless steel here generally the chromium percentage is 11 to 27%. Little bit here I am just discussing about its property. It generally possesses a microstructure which is purely ferritic type, you know. Now, it is also it is a magnetic and it has very good ductile properties, you can say it is a ductile types of steel. And you should keep it in mind, in anneal condition it develops its maximum softness, ductility and corrosion resistance. This also you should keep it in mind. This is generally ferritic steel. So, this ferritic steel is more sensitive to weld induced hydrogen induced cracking. This you should keep it in mind. That is why what happens, this post weld heat treatment mainly we use for ferritic types of steel, where hydrogen cold cracking is a major concern. And what happens, it is also the more critical once the thickness of this ferritic steel is little bit higher range. That is why I have written, it is also this hydrogen induced cold cracking also more sensitive if the thickness of the plate is higher. Okay. Now, first of all I will discuss briefly about what is post heating and what is stress relieving. In post heating generally the weld is not allowed to cool to room temperature, this you should keep it in mind. That means, after welding the weld is not allowed to cool to room temperature, rather it is maintained at some elevated temperature for a period of time, this you should keep it in mind, then allowed to cool down room temperature. It is generally this post heating process, which is a post weld heat treatment process. It is a low temperature heat treatment process which is generally carried out immediately after completion of welding by increasing the preheat by around 100 degree centigrade temperature. That means, by increasing the temperature around 100 degree above this preheating temperature and maintaining this temperature for a period of around 3 to 4 hour times, what I am telling, understand. Once we maintain this temperature around 3 to 4 hour time, then what happens, whatever the hydrogen generally entrapped inside the structure, that generally get more time, and what happens, this hydrogen diffusion its out from this weld as well as heat affected zone, then what happens, chances of weld induced cold cracking reduce drastically. What is it done, you got the idea. That means, here initially let us the welding started from some preheating temperature, that preheating temperature let us consider around 220 degree centigrade temperature. So, what happens, and this is your room temperature, let this is room temperature is 25 degree centigrade temperature. So, what happens in case of this post heating, here the temperature is goes like this, after that generally here it is come down to around what it is called preheating temperature, After that, here instead of its cool down to room temperature, here we increase the temperature around 100 degree centigrade. After that, we keep this temperature, or you can say this is called soaking time. What it is called? Soaking time. We hold this temperature for a particular times. After that, generally we cool this, slowly we cool this to room temperature. What I am telling, understand? So, this operation is called generally post heating operation. What I am telling, understand? Post heating operation. This you should keep it in mind. Okay. This operation generally is called as post heating operation. Here this is represent your temperature and this curve represent your time. Okay. So, here that is why I have written this post heating generally diffuses any hydrogen in the weld and heat affected zone out of the joint, and it reduces the risk of hydrogen induced cold cracking. Now, although there are various types of code and service requirement can dictate a variety of temperature, but generally a common post well post heating temperature is generally we use that common post well heating temperature generally we use consider as 230 degree centigrade temperature. This is a common post heating temperature. This is generally maintained for 1 hour, you can say, once a plate for a plate thickness of, you can say, for a thickness of 25 millimeter. This you should keep it in mind, that we have written. That means, for 25 millimeter thickness we keep this what it is called post well heat treatment temperature for 1 hour. Now, another post well heat treatment process is called stress relief heat treatment process. It is generally a separate heat treatment process. It is generally performed after the welding had cooled to room temperature. So, here generally the temperature of the weld specimen drop down to room temperature. After that, generally we reheat that weld specimen to a temperature about 600 to 750 degree centigrade temperature, and we hold this temperature, that is called soaking time. Here you can say hold this temperature for a period of around 2 to 4 hours. Then generally it is cooled down to room temperature. What it's happen in case of a stress relief, a little bit here I am showing by plotting the curve, then it will be more clear to you. Like let this is your temperature T and this is your time. So, what happens here generally, what we used to do, we start the heating, then we cool down this plate and it is come to room temperature, it is come to room temperature. So, once it come to room temperature, then from this zone we generally raise the temperature to a temperature of this temperature I am just showing, this temperature is around 600 degree centigrade, 600 to 750 degree centigrade temperature. What I am telling, understand? And this whole time or soaking time generally here we use, this time generally is around 2 to 4 hours, hold this time. After that generally we cool down to room temperature. This you should keep it in mind. This is generally called stress relief operation. Now, in details about post heating and stress relief post oil heat treatment I will discuss in this in the subsequent slide. So, what we note that susceptible steel typically experience cold cracking around ambient temperature, that we observed in previous lecture also we observed. So, it is possible to avoid this cold cracking by allowing the hydrogen to diffuse from the weld before weld cool down to room temperature. That means, before reaching the room temperature, if we can able to eliminate the hydrogen which is entrapped in heat affected zone as well as weld zone, then what happens? We can avoid this HIC, that means hydrogen induced cold cracking phenomena. So, that is why generally this post heating heat treatment is widely used, you can say. The there are three different options generally we can consider for what is called post heating operation. That means, you can say there are three different types of process we can use for post heating operation. Like in option 1, what we used to do, which I have already discussed in previous slide, that you can say here generally upon completion of the welding in this option, upon completion of the welding, the weldment generally maintained at THP, that means at preheating temperature, or you can see if it is multi-pass types of welding, they are generally you can say interpass temperature for a period of time. So, here what we used to do, after completion of welding, we generally hold the preheating temperature for a particular time. The soak time, whatever the soaking time is there, that soak time should be sufficient to allow hydrogen diffuse and relieve the and also relief of residual stress. That this soaking time should be such, residual stress should be minimized, as well as hydrogen should allow to diffuse, that means hydrogen should diffuse out from that zone. So, that is why what we used to do in option 1, here generally we used to temper the whatever the martensitic structure form during cooling from welding temperature to preheat temperature, whatever the martensitic structure it form, that martensitic structure generally we tempered. That temperament is done at a temperature of, that is generally preheating temperature, you can say. That preheating temperature is around 220 degree centigrade temperature, what I am telling, understand. That is why here I have written tempering of the martensite that are formed during cooling from welding temperature to preheat temperature. Then what happens, apart from this thing, by this option 1, whatever the what it is called untransferred austenite are there, that untransferred austenite also we transform to some other phases, which is generally you can say some soft phases, you can say other phases like such as bainite, due to this option on post weld heat treatment. So, what we used to do, you got the idea. Here instead of cooling to room temperature, we hold the generally weld specimen for a preheating temperature. Preheating temperature means it is generally around martensitic starting temperature range, this you should keep it in mind. Within that temperature range we hold it, or you can say we temper the weld specimen. Due to these things, whatever the martensitic structure already formed due to cooling from weld temperature to preheating temperature, that martensitic temperature generally you can say convert to ferrite plus carbide structure. Apart from these things, if there will be some untransferred what is called austenite, then that untransferred austenite also during this what it is called post heating time, it is converted some other phases like bainite types of structure. Then we generally cool this steel slowly and uniformly to room temperature, slowly and uniformly to room temperature, this you should keep. This is generally option 1. But here one thing you can observe, that here generally this post heating temperature here generally is comparatively it is less, this you can say. For this post heating purpose, what it is called, there may be a code requirement. For example, like for ASME section 3 and what happens NBIC, the full form of NBIC is National Board Inspection Code, both have such provision. Generally this type of for post heating purpose generally there may be required some code. What are those code? These two codes generally very popularly used. Like for this section 3 requirement for carbon manganese, or you can say low carbon steel material, here this post heating temperature is varying from 450 to 550 degree Fahrenheit. In centigrade it is 230 to 290 degree centigrade for minimum of 2 hours, this you should keep it in mind. So, according to this section 3 ASME code, we should do the post heating by this temperature and this minimum time, otherwise our post heating will not be satisfied the what it is called this code. Apart from this thing, another code also is there, that is called NBIC. I have already told you, National Board Inspection Code. Here generally the requirement is around 500 to 550 degree Fahrenheit, in centigrade it is 260 to 290 degree centigrade for a minimum time of 2 hours. This is also you should keep it in mind. So, if we follow this code, then what happens? There is a chance of less hydrogen induced cracking, and there should be as minimum as well induced residual stress also, if we will do this thing. But here one things you can observe. So, here generally I have shown these things how this post heating is done. So, after welding or last pass, we hold the or raise the temperature to around 450 degree Fahrenheit. After we hold these things, I have already told you 1 hour generally for 1 inch, or you can say 25 millimeter thick section and thickness. After that generally we cool down to room temperature. Okay. This you can observe from here. Now, as here this temperature range in post heating is comparatively less, that is why here I have written, you can say this TPH, that means preheating temperature and interpass temperature being typically low. So, what happens, are not sufficiently high to allow for fast diffusion rate, that means it is not allow fast diffusion rate of this hydrogen, what I am telling, understand, or effective relief of residual stress also. That is why to shorten this soaking time required for hydrogen removal and to provide a more complete stress relief, some manufacturer adopt option 2. This you should keep in. What is option 2? In option 2, what are the things we used to do? Here generally instead of holding the temperature within a range of around 230 degree centigrade, here generally we raise the temperature little bit higher level. That thing generally, what is this higher level? This temperature generally we raise to around 600 to 750 degree centigrade temperature of various types of steel, and this temperature also should be below recrystallization temperature. So, here instead of within that range to 230 degree centigrade, here we raise the temperature around 600 to 750 degree centigrade temperature. So, once we raise this temperature, then what happens here, that means removal rate of hydrogen is more, as well as here generally you can say effective relief of residual stress also more. That is why this option also sometimes we use. What is option 2? In details little bit I am telling. Upon completion of welding, what we used to do, the weld mesh is heated directly from whatever the preheating temperature were there. That means, here also we are not cooling down the cooling down to room temperature. Here we generally cool down up to first TPH temperature, then to then after that what happens, heated directly from this TPH to some higher temperature. So, what we used to do here, let this is our preheating temperature, we heat it, after that we cool down to preheat temperature, not room temperature, let this is our room temperature, this is our let T room, I am writing T room temperature, then let this is our TPH temperature. So, what we used to do here, from this preheat temperature we heat the plate, then cool on its cool down, then from preheat temperature here we raise the temperature to around 600 to you can say 750 degree centigrade temperature. After that we cool down to this room temperature, you see, cool down to room temperature. So, this is whatever the hydrogen generally entrapped inside the heat affected zone or weld zone, that generally escape rapidly. And here generally another things you should keep it in mind, here the soaking period of time also here around 2 to 4 hours. After that generally we cool the steel down to room temperature. This is option 2.